right, welcome back everyone to the review of the chain rule. Now, last lesson we discussed what the chain rule was. Now this is just a quick overview of everything involving the chain rule again. So, what we're going to do after today, and you guys are already experts, now you need to be better experts at using the product rule with the chain rule, using the quotient rule with the chain rule, finding some trig functions with the chain rule, and doing other types of things, including using the chain rule more than one time. Alright, so let's just start off. What is the chain rule? Alright, you haven't done this too long ago, probably yesterday or a couple days ago, so you should remember. What you do is you're going to differentiate a function inside a function. And when you do that, what you're going to do is, first thing you're going to do is find u and f of u. U is the inside function, f of u is the outside function. Then you're going to derive both u and f of u. Then you're going to plug the derivative of u and the derivative of f of u into this equation. And you are going to solve and then plug the original u back into wherever you have an original u and simplify. And that's it. A lot easier said than done. Some quick shortcuts when using trig functions, and this sheet will be given to you when you take your test. Finally, the derivative of sine, you would just take whatever the derivative was inside here, derive sine itself, and then put this back right in with there. All right? And we went over this multiple times, and I'll go over it when we go over it. All right, and then you have your quotient rule, f prime g minus g prime f over g squared, and your product rule, f times g prime plus g times f prime, and of course, our chain. All right, so let's start off pretty easy. Now, how do you know when to use the chain rule? When you're raising a large function that has multiple pieces inside to a power, you're going to use the chain rule. So, our u is our inside piece right here, which is x to the 8th plus 9x to the 5th minus 88x squared minus 6. And our f of u, our outside function, is that whole thing, which we're going to just turn into a u, to the 7th power. So this is also kind of like doing almost like a substitution method. We'll deal with that when we do integration later on. You derive this. You're going to derive this using the simple power rule. Power rule is x to the n equals n times x to the n minus 1. So this becomes 8x to the 7th. 9 times 5x to the 4th is 45x to the 4th. Negative 88 times 2x is negative 176x. And the derivative of negative 6 is 0. Derivative of u to the 7th, now you're going to derive that in terms of u, all right, is just 7u to the 6th. Now, after you did this part, you're going to just plug it back into the original equation. 7u to the 6th times your u prime. Now, because this is a simple equation, you can actually take your 7 and you can distribute it to each one of these if you'd like. You don't have to, though. You can just leave it as 7 times this whole equation times u, which is our x to the 8th, 9x to the 5th minus 88x squared minus 6, all to the 6th power. And then you're done. See? 7u to the 6th times this. Right? If you want to distribute the 7 into this portion, you can. But like I said before, you do not have to. Right? Look at problem number 2. You're going to rewrite this. Anytime you have a cubed root, it is whatever that is to the 1/3 power. Once again, the inside is your u. The u to the 1/3 is your outside function. 7 times 4x to the 3rd minus 5 times 2x plus 0 is 28x cubed minus 10x. Derivative of this is 1/3 u. 1/3 minus 1 is 1/3 minus 3 over 3, which is negative 2/3. Multiply these two pieces together. All right, when you do that, you get 1/3 u to the negative 2/3 times 28x cubed minus 10x. All right, 1/3 times this. U is 7x to the 4th, 5x squared plus 6, negative 2/3. And that's all you have to do. All right, see, not that difficult. All right, problem number 3. Tan u equals secant squared u times u prime. So we know what that is. So what we're going to do is we're going to use the chain rule. The inside right there is going to be my u. So I'm just going to write out head this. If you want to do this in your head, you can. My outside is the actual trig function, which is tan u. Our u prime is the derivative of this, 6 times 3x squared minus 9, which is 18x squared minus 9. Derivative of tan u is secant squared u. Now you don't have to put the u prime here because we're not doing this in one step. We're just using the chain rule and actually doing it in 2 steps. Okay? If you want to do it in 1 step, you would just pretty much take this and multiply it by secant squared this, which is what we do in the end. So we have secant squared u, which is secant squared 6x cubed minus 9, times 18x squared minus 9. All right? Typically, you want to pull whatever functions you have in front of the trig function. That's why we write it as 18x squared minus 9 times secant squared 6x cubed minus 9x. Right? Chain rule is easy. Now this one, you got to rewrite this. This is not cosine x to the 4th power, but what this actually is cosine x the whole thing to the 4th power. So our u is cosine x. Our f of u is u to the 4th power. Our u prime derivative of cosine is sine. Okay, so we're not really using this formula. What we're really just using is derivative of cosine x equals sine, negative sine x. F prime u is 4u to the 3rd. Okay, so multiply these by each other. 4u cubed times negative sine x. The negative goes in front of the 4, so it's negative 4u to the 3rd sine x, and our u is cosine 3. So it's negative 4 times cosine x to the 3rd power sine x. And remember, as I said earlier, you don't really want to write it like this. We take the 3 and we put it next to the cosine. So it's negative 4 cosine cubed x times sine x. Alrighty? Awesome. Problem 5. You know what we have to do here? Now we're going to have some fun. I see something inside of something. So, the inside here is all of this, and the radical u to the 1/3 is the outside. So u is 5x to the 7th minus 2x cubed minus 17x to the 4th. F of u is u to the 1/2. Now, hopefully this ages well. No. It's been a couple of years. So, how do we find u prime? You have to use double chain rule. Sorry, not copyrighted. So, what you have to do here is, you're going to take this part right here, 5x to the 7th minus 2x, right? Use 2 chains. And you're going to chain rule it. So, the u is the inside, which is 5x to the 7th minus 2x. F of u is u to the 3rd. U prime, the derivative of this, u, not the big U, the u inside the u. 5x to the 7th minus 2 is 5 times 7x to the 6th, which is 35x to the 6th, minus 2. Derivative of this is 3u squared. Okay, so keep following. Multiply these two. 3u squared times 35x to the 6th minus 2, right? Now, here is the key that you don't want to make the mistake. When you plug your u back in, you're plugging in the u from the section that we're doing. We're just treating this as its own problem, so you forget everything else as we do this problem. So we're going to plug this in for u. So it's 3 times the u prime. We're going to distribute it. That's 105x to the 6th minus 6 times u squared, and then that u, we can almost do an arrow. This u goes in there. All right, so it's 105 x to the 6 minus 6 times 5x to the 7th minus 2 squared. Now, this purple part, we don't use anymore. We just use the purple. But don't forget about the minus 17x to the 4th. What do we do with that? You just derive it normally. So it's negative 17 times 4x cubed, which is minus 68x to the 3rd. All right, so this now is my whole u prime. F prime u, 1/2 u to the negative 1/2. So our last step, we're going to use this formula again. We're going to plug in just these two into the formula. So you got 1/2 u to the negative 1/2 times all of this. Ready for the last step? What u do we plug in? Remember, this purple stuff is done. We plug in our original u right here. Our original u. So that gets plugged in for u. So our final answer is, and look, we're not reducing things, we're not making things easier, we're just writing this out. 1/2, 5x to the 7th minus 2x cubed minus 17x to the 4th, to the negative 1/2, times 105x to the 6th minus 6 times 5x to the 7th minus 2x squared minus 68x cubed, and then we bracket that. That's it. Big, long problem, answer, but it's actually pretty easy, isn't it? No? Well, it should be easy. 6. Wait till you see what we're doing next. Ooh, the next problem's even worse. What are we doing here? That's the key. Figuring out what way to solve this. So what is your first step here? There's your hint. Product in a chain. So are we doing chain rule first or product rule first? Product rule. You're multiplying an f and a g to each other. Our f is our first function, 5x to the fourth minus 3x squared. Our g is our second function, 8x cubed plus 11 to the sixth power. Oops, so sorry, I derived this already. 5x to the fourth minus 3x squared, derivative of that, 5 times 4x to the third minus 3 times 2x is 20x cubed minus 6x. Sometimes I forget what order I put this stuff in. And then my g is right here. All right? In order to derive g, what do we have to do? Chain. All right? So, our u is our inside, 8x cubed plus 11. Our f of u is the outside where you're raising it to the sixth power. 8 times 3x squared, 6u to the fifth. U prime times f prime u, 24x squared times 6u to the fifth. Multiply 24x squared times 6, all right? 120, 130, 144, u to the fifth, x squared. Now we're going to take our u right here, and we're going to plug it in for that. And when we do that, we get 144 x squared, 8x cubed plus 11 to the fifth power. Right. See, colors make everything a lot easier. Now, formula we use, product rule formula. F times g prime, 5x to the fourth minus 3x times 144x squared, 8x cubed plus 11 to the fifth, plus 8x to the third plus 11 to the sixth times f prime. Now, how do we simplify this? Only one way, really. This and this, you're not going to combine because when you raise something to a power, you don't FOIL it. Raise to a power, but I can distribute the 144 to both of these. If you don't, you're still right, it's fine, but it's nicer to clean it up just a little bit, or at least put the 144 up front. So 144x squared times 5x to the fourth is 720x to the sixth. 144x squared times negative 3x squared is minus 432x to the fourth. And then, as we said before, it's times this stuff. I put the 20x to the third minus 6 in front, and then I put my x to the sixth. It doesn't really matter which way you do it. It's just how I did it. I just swapped these. Do you have to swap them? No. But there's your answer. Look at this. Would you have ever thought a couple months ago you'd be able to get answers like this? I know I said that before, but it's great. That's why on the first day of school, or when your parents come to school, I show them problems like this to show them how smart you guys are going to become. You're already smart when you start school, but you get more smart, and then you get all surprised and like, whoa, I can't do that. They're not getting help from me. That's why they get scared when we first took class. Anyway, what do you see there? I see division. Division is quotient rule. So, quotient rule, and I have something raised to the fourth power on bottom, so I'm going to use the quotient and the chain rule. What's my f? The numerator. It's negative 7x squared, derivative of that, negative 7 times 2x is negative 14x. My g is my denominator. Because this is raised to the fourth power, what do you have to use? The chain rule. What's my u? The inside, 2x cubed plus 212. F of u is u to the fourth power. 2 times 3x squared is 6x squared plus 0. 4u to the third power. Boom! 6x squared times 4u to the third. 6 times 4 is 24. X squared, u to the third. And we plug this u back in, so it's 24x squared times 2x cubed plus 212 to the third power. All right? Follow the arrows. Don't forget to use the quotient rule formula. Too many people do this, get all this right, then use the product formula. It's division. You need the division formula. F prime g, negative 14x times 2x to the third plus 212 to the fourth power, minus 24x squared, all this stuff to the third, minus 7x squared, all over. Do not forget g squared. Okay? Now watch what happens here. This can't be reduced, so that stays the same. This, we have a negative 24x squared, and we have a negative 7x squared. So we can reduce that. We can also raise a fourth power squared That means you multiply. 4 times 2 is 8. All right? Oh, there it is right there. So when I multiply these two, 24x squared times that, I end up with the beginnings the same. Now this becomes a plus because it's two minuses, 24 and negative 7, and negative 24 is 168. X squared and x squared is x to the fourth. This stuff to the third, all over 2x cubed plus 212x to the eighth. Now, you don't want to stop there, do you? Do you notice anything about this function? One function, two function, three function. They all have what involved? A 2x cubed plus 212, 2x cubed plus 212, 2x cubed plus 212. Well, this one has 4, this one has 3, and this one has 8. So I could take some out, right? I could take how many out? The number that's the less. So I could take out 3. So if I take out 3 of these, I'm left with none. If I take out 3 of these, I'm left with just 1. And if I take 3 from 8, I'm left with 5. Now, your answer is negative 14, 2x cubed plus 212 plus 168 x to the fourth over 2x cubed plus 212 all to the fifth power. You don't want to leave it like that though, do you? No, we can go further. How do we go further? We can take this negative 14x and we can distribute it. Negative 14x times 2x cubed is negative 28x to the fourth. Negative 14x times 212 is negative 2,968x plus 164x squared over 2x cubed plus 212 to the power. Well, why stop, right? We have a negative 28x to the fourth and a positive 168x to the fourth. 168 minus 28 is 140x to the fourth minus 2,968x over this to the fifth. All right? See? Easy, easy, easy. You can take numbers out of the top and bottom still, but that's good. All right? If you left it in this form, you'd be okay. This makes it a little nicer though. All right? Soak it in. All right, problem number 8. A little different. What's the difference here? What are you going to start with? Well, you're raising something to a power. So do you start with the quotient rule? No, you actually start with the chain rule. So my u is everything inside. My f of u is everything inside, which is turned into a u to the fifth power. How do you know the difference? Well, when you raise everything to a power, that's when you start with the chain rule. When you have something raised to a power inside a division problem, that's when you start with the quotient rule. In order to derive u, we have to use our quotient. 11x cubed is our f. Derivative of that is 33x squared. G, 5x squared minus 1, 10x. And they got 0. What is it? F prime g, 33x squared times 5x squared minus 1. G prime f, 10x times 11x cubed, all over 5x squared minus 1. Quantity squared. Distribute to 33. 33x squared times x to the fourth is 165x squared minus 33x squared minus 110x to the fourth. Combine like terms. 165 minus 110 is 55x to the fourth over 33x squared all over 5x squared minus 1 squared. If you want to take an 11x squared at the top, you can. Leaving with 5x squared minus 3, but that doesn't really do anything, so you don't have to. F prime u, this one's easy, 5u to the fourth. Ready to finish things off? This times this, that's your chain rule. So you got 5u to the fourth times what we found out to be u prime. We're going to plug our u back in, which is 11x cubed, times 5x squared minus 1. We're going to raise that to the fourth power. If you want, you don't have to, you could raise both of these to the fourth power and make this whole denominator 5x squared minus 1 to the sixth. And then it'd be whatever 11 to the fourth power is times x to the 12th times this times 5. And then you can put the 5 in if you want. But if you leave it like this, perfectly fine. All right. As you can see, my space constraints. Constraints. All right, number 9. We're making some good progress here, right? This review usually takes like 2 days in class. Negative 7 cotangent to the fourth minus x squared minus 6. What do you think we're using? What do you think? Well, this cotangent to the fourth means it's negative 7 times cotangent negative x squared minus 6 all to the fourth power. So now what do you think we're using? Chain rule. The inside cotangent negative x squared minus 6 is your u. We're actually using the double chain. And then you're going to have to find the chain of this inside. It's back. Always comes back. So let's go check this out. Our u, cotangent negative x squared minus 6. F of u is negative 7 u to the fourth power. And here comes the double chain. Boom! We're going to have to use this chain now to find out the cotangent thing. Now you can do this in your head if you'd like. Or you can just write it out. Writing it out is sometimes easier when it's not just like a simple function in there. U negative x squared minus 6, f of u cotangent u. U prime, negative 2x minus 0. F prime u derivative of cotangent is negative cosecant squared u. Negative 2x, which is our u prime, negative cosecant squared u. See, that's where this comes from. This just jumps from here to here. I just showed the work to get there. So negative and a negative is a positive 2 x cosecant squared u. And we plug back in the u from the subproblem. So it's 2x cosecant squared negative x squared minus 6. Negative 7 times 4u to the third is negative 28u to the third. Multiply the two together. See, the two chain rules was actually pretty easy. Negative 28u to the third times the u prime we found. Negative 28u to the third times 2x is negative 56x. U, our original u, cotangent negative x squared minus 6 to the third power, cosecant squared, negative x squared minus 6. And the last step here, this is technically right, this is okay. You're just going to take this 3, and where do you put it? Next to the cotangent. So it's negative 56x, cotangent cubed, negative x squared minus 6, cosecant squared, negative x squared minus 6. Look at that. Math with letters, numbers, signs, two chains. Awesome. All right, number 10. This one looks like a fun one. Oh, we're only at 22 minutes. That's pretty easy. All right, what do we got here? That's like two minutes of problem. Here's your hint. That hint help you? All right, so you're going to use a quotient rule now with two chains. I should put CHINZ. Yeah? No? All right. Anyway, first thing you have to do is a quotient rule. The numerator is negative sine 6x. Your denominator, 1/2 x to the fourth minus 9 to the fifth. So we're going to have to use the chain rule to solve this. Once again, you can do this one in your head. Your u is 6x, your f of u is negative sine u, 6 and negative cosine u. Or I can just do the derivative of this is 6, derivative of this is cosine, negative 6 cosine u, negative 6 cosine 6x. Up to you how you want to proceed. This one, we got some chains in here. This one you have to do power rule stuff. 1/2 x to the fourth minus 9, f of u is u to the fifth. Like I said, power rule, 1/2 times 4x cubed minus 0 is 2x cubed. 5u to the fourth, multiply the two together. 2x squared cubed times 5, 10x cubed, u to the fourth. 10x cubed, 1/2 x to the fourth minus 9 to the fourth power. See, that 1/2 thrown in there just makes things look a little scary. It's not really that bad. Back to the quotient formula. Negative 6 cosine 6x times 1/2 x to the fourth minus 9 to the fifth power. All right. Minus 10x cubed 1/2 x to the fourth minus 9 to the fourth power times negative sine 6x all over g, which is 1/2 x to the fourth minus 9 to the fifth squared. Whoa, that looks crazy, doesn't it? Let's do some simplification. This stays, right? Negative and a negative is a positive. All right. And 5, 2, the fifth power squared is a 10th power. So you get negative 6, 1/2 x to the fourth minus 9 to the fifth. I just move the cosine over here. Cosine 6x plus 10x cubed. 1/2 x to the fourth minus 9 to the fourth, sine 6x, all over this to the 10th. Now, why do we simplify this out? Well, look what I have. 1 half x to the fourth minus 9 to the fifth. 1 half x to the fourth minus 9 to the fourth. 1 half x to the fourth minus 9 to the 10th. 10, 5, 4. Smallest number is 4. I'm taking all these away, making this a 1. Taking all but one of these away, leaving this. And taking 4 from 10 is 6. Negative 6. 1 half x to the fourth minus 9, cosine 6x, plus, that's gone, 10x cubed, sine 6x, and this is left to the 6. All right? You can go one more step. What's the last step? Multiply negative 6 to this, distribute it. Negative 6, half of it is negative 3, and that's 54. Negative 3x to the fourth plus 54 times cosine 6x plus 10x cubed sine 6x. All over 1 half x to the fourth minus 9. Whew! Fun problem? You got that, right? Yes. See, you guys can't do them as quick as me, but as long as you can do them, you're good. And just so you know, when I'm doing these right now, I don't have notes or anything. You can look around. I'm doing these straight from my head. And I haven't done these in a while, so not that bad. So as fast as I'm going is usually as fast as it takes me. So it should take you about 2 to 5 times as fast, just because I do these all the time. All right, number 11. What are we using here? Anyone? We are using starting with the product rule. F is negative 7x squared minus 1 to the 1/3 power. Okay, the only reason I'm doing 1/3 is you want to just make it exponents here. 5 over 2x to the 7th minus 8x cubed to the 4th power. Product with 2 chains. All right, so F is this, negative 7x squared minus 1 to the 1/3. G is 5 halves x. You could actually also write this if you want. 5 half x to the negative 7 minus 8x to the 3rd, all to the 4th power. What do we have to solve both of these with? We need 2 chain rules. Okay, so this just becomes like 2 smaller problems in one problem. With this chain rule right here, the u is obviously the inside, negative 7x squared minus 1. F of u is u to the 1/3. Negative 7 times 2x is negative 14x. This is 1/3 u to the negative 2/3. Remember, 1/3 minus 3 over 3 is negative 2/3. Multiply these guys together. You get 1/3 u to the negative 2/3 times negative 14. This just becomes negative 14 over 3x. U to the negative 2/3, which is negative 14/3 x. This little u in here, negative 7x squared minus 1 to the negative 2/3. Good so far? We are 1/3 of the way there. U is the inside. 5 halves, like I said before, x to the negative 7th minus 8x cubed. F of u is u to the 4th. 5 halves times negative 7x to the negative 8, because negative 7 minus 1 is negative 8, minus negative 8 times 3x squared, which is negative 24x squared, 4u cubed. Multiply these by each other. Now, 4u cubed, we're just going to take this and we're going to distribute the 4 to both of these. All right? Leave the u cubed by itself. We don't want to really distribute the u cubed because it gets a little crazy. 4 times this is negative 70 x to the negative 8 minus 96 x squared times, we're going to plug our u back in, which is 5 over 2x to the 7th minus 8x cubed to the 3rd. If you want to leave this in the negative 7th form, that's perfectly okay. It's all personal preference. But now, we don't need our chain rules anymore. So we could use our product rule. Product rule is, where's our product rule? I don't even got it here. All right, product rule is f times g prime. Negative 7x squared minus 1 to the 1/3 times negative 70x to the negative 8 minus 96x squared times 5 over 2x to the 7th minus 8x to the 3rd cubed plus g f prime 5 over 2x to the 7th minus 8x cubed to the 4th times negative 4 over 3x negative 7x squared minus 1 to the negative 2/3. Now let's look. Can we clean this up at all? So this, we can leave this almost like this, but here's what I don't like. I don't like the order. So all I'm going to do is change up the order. Now mainly, I'm just going to bring the cube first. Then I'm going to bring them on with no exponent. and then I'm going to bring the exponents to the third power. So I'm just going in descending order. You don't have to do this, but that's what I prefer. My negative 14 over 3x, this is what I really want. I really want that right there, because you really don't want to do plus and then have a negative inside the equation, so the minus here is important. 14 over 3x goes before the other stuff, and then I go in descending order. All right? So this is technically the right answer. All right? You just rearrange, I rearrange the answers too. All right? That's pretty impressive to get an answer like that, isn't it? Should be proud. We're almost done. All right, that's actually the end of the review. And then during the review last year, or 2 years ago, or 1 year before, I made these lessons online, which I think are spectacular. And you guys are lucky we had the lockdown so I could have time to do this. These two bonus problems are problems that students had a little extra trouble with. So I just threw a couple bonus problems on here, and let's see how they work out. Solve it. I don't know if this is in the packet. So when you solve this, it's this stuff to the 3/4 power. Ah, that got some people. So this is actually a chain and a chain. You have two of them. Your u, 7x to the 4th minus 10x, all to the 4th power, plus 10x squared. F of u is u to the 3/4. We're going to need a chain rule to solve the 7x to the 4th part of this. Where is that? Oh, there he is. There's my double chains. All right. U is 7x to the 4th minus 10x. F of u is this, which is u to the 4th power. 7 times 4x cubed minus 10 times 1 is 28x cubed minus 10. And this becomes 4x cubed. Multiply these two together. 4u to the 3rd times 28x cubed minus 10. You're going to take the 4 and you're going to distribute it to both of these. 4 times 28 is 112x cubed. 4 times negative 10 is minus 40, and that's all times u to the 3rd power. So your final answer is 112x to the 3rd minus 40, 7x to the 4th minus 10, all to the 3rd power. All right, f of u is 3/4 u. 3/4 minus 4 over 4 is negative 1/4. Oh, I did it. I'm jumping ahead. I forgot to derive the plus 10x squared over there. It got hidden with all these colors. And the derivative of that is 10x, 10 times 2x, which is 20x. There's your 3/4 shoots to negative 1/4. Don't forget this guy. See, I haven't forgot it. Multiply these two in the end. So you got 3/4 u to the negative 1/4 times all this stuff. All right. So your final answer is, yes, you could do 3/4 times and distribute it in here. That's way too crazy. So just leave 3/4 out front, plug my u, my original u back in, 7x to the 4th minus 10x to the 4th plus 10x squared, all right, to the negative 1/4 times all this stuff. There we go. That's your final answer. If you want to do 3 times this over 4 times this, the 4th root of that, you can do that, be my guest, I don't care. This is the easiest way to write that. Ready for one more problem? Last problem of the day. Oh, it's some trig with some stuff. So you first rewrite this. Oh, wait. You did the problem already? Don't just copy this. You have to do the problem on your own first. All right. Now, negative 10 sine negative 9x to the 3rd plus 18 all to the 8th power. So my first inside-outside stuff, inside would be sine all that stuff. All right. Another double chain. See, I just missed putting up double chain, 2 chains. U sine negative 9x cubed plus 18x. F of u, negative 10x to the u to the 8th. All right? What do you got next? U prime. U is the inside of the trig function, negative 9x cubed plus 18x. F of u is sine u. U prime, negative 9 times 3x squared plus 18 times 1 is negative 27x squared plus 18. Derivative of sine is cosine. U prime times cosine u. Negative 27x squared plus 18 times cosine, this u right here, negative 9x cubed plus 18x. F of u is negative 10 times 8 u to the 7th is negative 80 u to the 7th. Ready to finish things off? Boom, boom, multiply the 2. Negative 80 u to the 7th. So you can distribute the negative 80 if you'd like. If you don't want to, you don't have to. Makes it look a little bit nicer. So our final answer is negative 80. I didn't even distribute it. Times this stuff. Times u to the 7th right here, all right, is sine 7, this stuff, times cosine this. If you did distribute this, this would be, what is that? 1,600 plus 540, like 2,140 plus, minus 640. 1,400? No. 1,440? I don't know, something like that. And then this stuff. I forget. You guys have calculators. You can do it. Alright, anyway, this is fine. Boom. Formula should be given. Trig functions. Chain rule, product rule, quotient rule. Power rule. Right? That's it. Hopefully. Actually, no, not hopefully. When you take the test, you will do good. It will be easy for you. And you will feel confident. And you will feel proud of yourselves when you're done. All right? So, that concludes pretty much all the types of derivations we're going to do when you just derive one variable. Next lessons, go implicit. So, good luck on your test. Study up. Any questions? Find me and ask me. Till next time.